Hi, this is Jason Baker, and welcome to our weekly lecture in DevOps and Cloud Infrastructure. This week, we're going to talk about Amazon Web Services VPCs, or Virtual Private Clouds. Now, virtual private clouds are more of an advanced topic in AWS, and I find that some students struggle with this topic because there are quite a few different network terms that and concepts that we use when describing how to configure and how to secure virtual private clouds. Now, if you don't have a networking background, don't worry, I'll talk you through some of the concepts, but you may need to do some independent research on your own to get familiar with some of the basic network concepts like IP network segmentation and setting up default routes and what that means for routing network traffic and so on. So be prepared to potentially spend more time working on this lesson than some of the other lectures in this course. So in the agenda for this week is to start out by talking about a couple additional services related to EC2. Last week we talked about the compute services and your ability to launch compute instances on EC2. This week, I'll talk about elastic load balancing, placement groups, and yet another storage service called EFS. And then I'll talk about virtual private cloud, VPCs, and how you can create your own private network, your own partitioned cloud within AWS. I'll talk about how you can set up natting and what that means and how that can provide you with greater security. And then finally, I'll end the lecture talking about some of the database services available in AWS, namely the relational database service and DynamoDB and Redshift. Let's get started. Well, the first service I wanted to talk about in the lecture was the Elastic Load Balancing Service, or ELB. And earlier in the course, I talked about some of the common patterns around distributed infrastructure. And the first pattern I talked about was the load balancing pattern, the ability of a load balancing service to take a request from a customer and then distribute that request across a fleet of servers. The load balancer can then help us horizontally scale our application, distribute the load of our application across multiple servers, and it can also monitor the health of individual servers to provide greater fault tolerance and service availability. Well, ELB is Amazon's version of a load balancer service. It's a load balancer that is designed to manage requests and distribute requests across EC2 instances. It provides a single endpoint that our external users and customers can use to send requests to, and those requests then are distributed across our servers. The ELB service can also monitor the health of our EC2 instances, and if the Elastic Load Balancer sees that one of our instances has failed or is unhealthy, then it can redirect requests to other instances in our pool of servers. The Also, when I talked about the load balancing pattern earlier in the course, I had noted that there were several different algorithms that load balancers can use to distribute requests. The Elastic Load Balancer service can leverage two different algorithms. And it depends on the type of Elastic Load Balancer that you build. The ELBs can implement a round robin type of algorithm for your sort of standard TCP requests. For HTTP and HTTPS requests, These are your web requests. The Elastic Load Balancers will implement the least outstanding requests algorithm, which means that the ELB uh, will send new HTTP and HTTPS requests to the instance which is supporting the least number of current requests. There are several benefits to Elastic Load Balancer service. Uh, this is a service that we use in almost any architecture where we're deploying a distributed application because we need some way to be able to distribute requests across several different instances. The ELB is really beneficial in this sort of architecture because it allows us to sort of elastically scale our services. We can scale up our services by adding more EC2 instances behind the load balancer. And then we can also scale down the service by reducing the number of EC2 instances to save costs in times where there's lower demand. And as I mentioned earlier, the load balancer can sense and detect the health of instances and redirect requests to other instances if it senses a failure. And this is particularly important when we want to deploy a highly resilient application because oftentimes what we would do is we would try to deploy our applications across multiple availability zones within a particular region. And that protects us against the failure of an entire availability zone. You can think of an availability zone as being like a particular data center location. And if a data center location is hit by some sort of natural disaster or man-made disaster, then the load balancer can redirect requests to other instances which are located in a completely different and geographically diverse availability zone. The ELB service is a managed service, which means that we can provide the ELB with a configuration. And in this case, we don't have to really manage any infrastructure. We don't have to spin up any instances or manage an operating system or application. We just provide AWS with some basic configuration information, and it completely manages the Elastic Load Balancer service for us. The service itself is priced on a per second basis, kind of like EC2 instances. And ELBs can scale up and down based on the demands of demand on our infrastructure. So if there's little demand, then ELBs are sort of scaled down to support whatever demand we have. And if we then burst up and we're consuming more bandwidth, then the ELBs can scale along with that demand. There are a couple other features available in Elastic Load Balancers depending on the type of load balancer we're deploying. And I'll show you what that means in the online segment of this lecture. One of the features we can deploy in ELBs are sticky sessions. And what a sticky session allows us to do is allows us to essentially bind a, a specific user's session to one of the instances behind the load balancer. Because typically when let's say a customer is accessing a website through the load balancer is going to redirect that customer to a new web server and the fleet of servers for every single web request that customer makes. There might be cases where we want to we want to sort of we want to sort of pin a customer's session, their web session to a specific server in the fleet. And so that every request that customer makes goes to the same exact server every single time, as long as that server is healthy. That's a feature we call it sticky sessions. Sometimes we call it session affinity. Generally, this sticky session feature is used for legacy applications that are don't sort of properly manage state in a centralized database. The second feature I'll talk about is SSL termination. When when a sort of like a website customer is sending a request to a website, if we want that request to be encrypted, then we enable SSL TLS, which requires a security certificate. And oftentimes that certificate is installed directly on the web server. It's part of the web server configuration. Well, if the web server needs to perform this encryption and decryption process, that requires a little bit of overhead. We can offload that encryption and decryption onto the Elastic Load Balancer so that when the client's web browser is sending a SSL TLS request, that request is then decrypted on the Elastic Load Balancer instead of on the actual web servers behind the load balancer. So we can terminate these SSL sessions on the ELB to offload some of the overhead, the CPU overhead from the servers to these Elastic Load Balancers. And then finally, when we think about load balancing, oftentimes we're thinking about taking requests from the outside world, from the internet, and distributing those requests across like a fleet of web servers. But we can also use Elastic Load Balancers to distribute requests between different application components that are sort of internal to the application. For example, I might have some sort of, let's say I have some sort of internal server running a RESTful API, and maybe that server is making requests to another internal server. Well, it could do so through an internal load balancer to distribute those internal requests across multiple servers. So this load balancing pattern isn't just used for requests coming from the outside world, from internet customers into our application. It's oftentimes used between different components of our application to provide to sort of horizontally scale those components and to provide fault tolerance. Okay, well, at this point, the best way I think to describe the Elastic Load Balancing service is to show you hands-on how you go about actually using this service in AWS. And what I'm going to do is I'm going to set up a demo where I launch two web servers running an a custom AMI that I built. And then I'm going to create an Elastic Load Balancer. And I'm going to configure that load balancer to send requests, to distribute requests to those two web servers. And then we're going to monitor the health and monitor the status of the ELB as I sort of remove one web server to simulate a failure, so that you can see how the Elastic Load Balancer responds to that failure event and then redirects requests to the other web server. So let's get started, and I will switch over to an AWS dashboard. I'm already logged into this dashboard, and the first thing I'm going to do is I'm going to go to the EC2 dashboard because I mentioned that I'm going to launch two instances and they're going to be running this specific AMI. So I'm going to copy this AMI ID so that I can use it here when I launch a couple instances. Okay, let's launch an instance. We're going to just use the Amazon Linux AMI. Oh, I'm sorry, we're not going to use the Amazon Linux AMI. In this case, we're going to use a custom AMI. So I'm going to click on My AMIs and search it for this particular ID. And it's actually this very top AMI called the Web Server Failover AMI. I'm going to select that. And yes, I want to continue with this AMI. And I'm going to use, these are just going to be T2 micro instances. Those are fine. Configure instance details. I'm going to use all of these default settings. In this case, I'm going to launch two instances instead of just one, so that these instances can launch in parallel. I don't have to go back and try to manually launch another instance. I can do both of them at the same time. I'm going to use the standard amount of storage. And I'm going to add a tag. In this case, I'm just going to say web server. Now I'm going to probably have to go back and maybe rename these because I want to be able to differentiate between the two. I'm going to create a new security group. And in this case, I'm going to add a rule to this security group, and I'm going to allow in port 80. So I'm going to go for the type and just select HTTP, which is port 80. For now, I'm just going to leave it to allowing everything in the world to access it. And I'm going to click on review and launch and go ahead and launch these new instances. Of course, I need to select my key pair. So I'll choose an existing key pair that I have access to, and I'll go ahead and launch these instances. Click on View Instances, and we can see our two instances launching. Now, I'm just going to rename this first one and just call it Web Server 1, and rename this other one, just call it Web Server 2, just so I can keep track of both of these instances. And at this point, I'm just going to pause and wait for these instances to be fully launched and up and running. At this point, both web servers are now up and running. So I've got two web servers, and what I want to do is create an elastic load balancer, which will accept incoming requests and distribute those requests across both web servers. So to do that, I create an elastic, I go to the load balancers link in the EC2 dashboard, click on load balancers, and this will allow me to begin creating an elastic load balancer. So I click on the create load balancer button. And the first thing that I'm presented with is this selection where I have to select the load balancer type. Now, for many years, there was only one load balancer type, which is now called the classic load balancer. And in past years, I've been using this load balancer in training with students. But in more recent years, Amazon has released two new load balancers, and they're gradually trying to push customers into using these new types of load balancers. So in this course, we're going to focus on using the newest generation of load balancers. And there are really two different types you can select from. There's an application load balancer and a network load balancer. The application load balancer is designed for web traffic. It's designed for HTTP and HTTPS protocol traffic, and it allows you to do things like set up SSL termination. And it provides some really helpful features that are designed, for web applications. The network load balancer is designed for all kinds of TCP traffic, and it's designed for extremely high performance. Uh, So if you have to load balance any other sort of network protocol, it might be like a database protocol, it might be some sort of, messaging protocol, then you would want to use the network load balancer. The classic load balancer can actually do both application load balancing and network load balancing. The challenge with the classic load balancer is that it, you can encounter scaling problems with depending upon your sort of what type of network traffic you're trying to load balance. So it's strongly recommended by AWS to use one of the newer generation load balancers for your newest applications. Now, in this case, we've got two web servers, and it makes sense to use the application load balancer because we're going to be load balancing HTTP traffic. I'll go ahead and click on the Create button under Application Load Balancer, and we're presented with a bunch of configuration information we can fill out. First of all, we give our load balancer resource a name. I'm going to just call this something like website ELB. And then we specify the scheme. And remember, I said that we can use load balancers to load balance external traffic that's coming in, or we can use it for internal traffic. In this case, for the ELB is going to be internet facing. It's going to load balance this incoming traffic from the internet. We're using IP version 4 network addresses, so we can leave that field at its default setting. And then we can configure the listeners. And the listeners is a really important configuration element in Elastic Load Balancers. The listeners specify what network ports the load balancer is going to listen on. And any traffic that the load balancer receives on those network ports is going to be then distributed to an internal group of servers. In this case, we're going to leave it at its default. We're going to be load balancing HTTP traffic, and that traffic is going to be coming over the standard HTTP port, which is port 80. We could set up multiple listeners. It's possible to set up an Elastic Load Balancer and allow it to load balance traffic on multiple network ports. So I set up that sort of configuration all the time. In this case, we just have one port that we have to deal with. And then we also need to select which availability zones we want to enable for our load balancer. The load balancer can route traffic to EC2 instances in multiple availability zones. Now, we need to select at least 2 availability zones if we want to configure a highly available environment. I'm just going to, in this case, I'm going to select all the availability zones within this US East 2 region and make them all available to our customers. Okay, well, next we need to configure the security settings. So I'll click on the next button here. And in this case, we're not going to be terminating SSL TLS on the load balancer. AWS is just giving us a warning and saying, hey, you're not running any sort of secure listener. And if you want to provide your customers with security, you should be encrypting your traffic using HTTPS. Well, this is just a demonstration, educational purposes. We're not using a security certificate here, so that's okay. I'll click on Next to configure security groups. Our Elastic Load Balancer, like other resources that we create, has to be associated with at least one security group. And if you recall from last week's lecture, the security group is like this set of firewall rules. It's a firewall that sort of envelops our resources in EC2. The key here is that we want the load balancer to be able to communicate with our systems on the internet, and it has to be able to communicate with customers out on the internet. At the same time, our Elastic Load Balancer needs to be able to communicate with our web servers. So what I'm going to do for now is I'm just going to assign this Elastic Load Balancer. I'm going to associate it with the same security group that our web servers are located in, so that it will be able to communicate to the outside world on port 80 on HTTP, and it will also be able to communicate with the web servers. Next, I'm going to configure routing, and this setting basically determines which EC2 instances the load balancer will distribute requests to. So the load balancer receives an incoming request and it's listening on its listener ports. It will take those requests and distribute those requests to what's called a target group. So we need to define a target group that will distribute those requests to. I'm going to give the target group a name. In this case, I'm just going to call it web servers. And it's going to distribute requests to those web servers over HTTP port 80. So it's possible to configure the Elastic Load Balancer so that it listens on one port, like port 80, but then it distributes the request on a different port, like port 8080 or something else. So that's entirely reasonable. In this case, our web servers are listening on port 80, so we'll just distribute the request to those servers on port 80. The targets are going to be EC2 instances, and so that's the target group. And then I'll show you in the next screen how we can associate our EC2 instances with that target group. The other configuration item that we need to complete on this page is a health check. The Elastic Load Balancer has the ability to make periodic requests to our EC2 instances, to the instances in the target group, to verify that those instances are responsive. And the Elastic Load Balancer, the way it makes those health checks is by sending a request, in this case over HTTP, and it makes a request to a specific path. And in this demonstration, the path is going to be a website file or page called index.php. So basically, the ELB is making a website request, and it's making a request to this web page on each of the target instances. And if that page responds with a proper response, then the ELB will consider that instance to be healthy. If I click on advanced health checks, you can see how I can specify a bunch of different thresholds and timeout values. And these values determine how frequently these health checks will be performed by the elastic load balancer, and how many retries the load balancer might attempt to do if a request fails. So if the load balancer makes a health check request to a target EC2 instance, and that target EC2 instance fails to respond to that request within a certain amount of time, which is known as the timeout value, then the the elastic load balancer might not necessarily fail the request. Like for example, in this case, it says unhealthy threshold is 2. So that the EC2 instance would need to fail that health check twice before the elastic load balancer would consider the instance unhealthy. And the load balancer would check every 30 seconds based upon this interval code. Once a instance is considered unhealthy, then the instance must successfully pass 5 consecutive health checks before it's considered to be healthy again. So these thresholds allow you to sort of tune these health checks to a great degree. And for this demonstration, I'm just going to drop the interval down to 15 seconds so that the interval is a little bit shorter. Now, you might be asking yourself, well, what are the right numbers to put in here? And the answer is that I don't have an answer for you, that it really depends on the nature of your application. These are numbers that you have to fine tune and work out for yourself over time. These default values kind of give you a sane starting place, but you would generally have to modify these based upon the nature of your particular application. Okay, I'm going to click on the next button. And so we've created this target group, but we haven't associated any EC2 instances with the target group yet. And that's what we can do in this step. We can register our targets. And you see two sections. You see registered targets and you see instances. The instances are the EC2 instances that are running in the availability zones that we enabled for our elastic load balancer. I can register these targets just by selecting both of them and clicking on the Add to Registered button. And now both of these EC2 instances are considered registered targets, meaning that the elastic load balancer, if it receives a request on port 80, is going to distribute that request to both of these both of these EC2 instances. I click the next button to review, and it shows me a kind of a summary of the configuration settings that I'm making for my elastic load balancer. I'm going to go ahead and click on the create button, and it is now in the process of creating the load balancer, and it does it fairly quickly. Now, it might take a little bit. It might take up to a minute for it to begin um, distributing requests to our EC2 instances. So I'm just going to pause it and wait for about a minute, and I'll come back. Okay, our elastic load balancer and instances and our target group is now healthy, and it took about a minute or so. There's a couple different things I want to show you in this dashboard. So we can see our website, Elastic Load Balancer. Uh, if I look at the description tab, there's a property here called the DNS name, and this is a really important property. This is the what we call the endpoint address. This is the address that we use to reference or access the Elastic Load Balancer. And you'll see me use this, and I'll type it into my browser window to send a request to the load balancer, and then you'll see that request is then distributed to one of the two web servers that are running on the EC2 instances. So you can see the state of this is active. You can see that we've enabled all these different availability zones. If I click on the listeners tab, you can see that we have enabled a listener. It's HTTP port 80, and the default rule is that it's forwarding traffic to our web servers. Now, if I want to see that target group, then I can go click on the target groups link in the load balancing section on the EC2 dashboard. And there you see my web servers. This is my target group. Again, these web servers are the target group is set up to distribute requests on port 80 using the HTTP protocol. And if I look at the targets tab, you will see that it shows me the instances that are registered as targets for the Elastic Load Balancer. I have web server 1 and web server 2. And this is important that you can see the status of each instance. So both of these are healthy. When I first launched that Elastic Load Balancer, the status of both of these just said initial, meaning that that the health checks were just starting up, and that the load balancer was waiting for these EC2 instances to pass the initial health check, which they both successfully did. So they're both marked as healthy. And if I click in the health checks tab, you can see again, here's the health check that I set up for the Elastic Load Balancer. Okay, let's now let's just try to access our website via the Elastic Load Balancer. To do that, I'm going to just copy this DNS name, and I'm going to paste it in a separate web browser tab. When I do that, then I get this very simple web page, or this web response. In this case, it says, "Hi, I'm instance," and then it provides us with an instance ID. That's a response from one of the web servers running on one of the EC2 instances. Now, if I refresh my browser, notice that this ID just changed. Each instance is going to respond back with a slightly different response, and each instance is going to respond back with its instance ID. So if I refresh, you can see how each time I make a request, the load balancer is distributing that request to a different EC2 instance. And each EC2 instance is responding back with its unique instance ID. If I go back to the console here and just click on the instances, just to prove that what's going on, if I select one of the instances like web server 1, and if I go directly to that public IP, I type that in a new browser tab. So I'm going directly to web server 1, and I just hit refresh. You see it's just always going to respond back with the same instance. So I'm going directly to that web server. But when I go through the ELB address, then it's load balanced and distributed across multiple EC2 instances. That's really the power of elastic load balancers. That's all it's really doing. It's a very simple but very powerful service, and it's a key pattern that we use when building distributed application architectures. Okay, well, let's pretend for a moment that one of our servers fails. So this is a failure event. Maybe the availability zone fails. Maybe this EC2 instance is just having a bad day, and so it fails. I'll go ahead and just simply stop web server 1. And then let's go to our target groups under our load balancers and look at the web servers and look at our targets. See what's going on. So when that web server 1 failed, you can see that the status becomes unused. So it says target is in the stopped state. The elastic load balancer recognized that the web server 1 is no longer responsive. And if I go to my ELB and just hit requests, you notice now it's no longer trying to distribute requests across multiple servers. I keep refreshing and the same instance keeps responding. So the ELB understands that one of the servers in the target group is no longer responsive, and so it will no longer try to distribute requests to that stopped instance or that failed instance. So that's how we use ELBs, and I hope you enjoyed the hands-on demonstration. We'll be using elastic load balancers throughout our different assignments and in-class projects this semester.